Okay, ladies and gentlemen, welcome to this webinar of the World Bioenergy Association on how India can become a global leader in sustainable agro-residue biomass production. We will wait for another minute because I can see many people pouring in, and then we'll kick it off. So bear with us, and we'll go live shortly. All right, I think we can kick it off. Ladies and gentlemen, I would like to welcome you all very warmly on behalf of the World Bioenergy Association. My name is Christian Rakos. I'm president of this association. We are, as an association, dedicated to the promotion of sustainable bioenergy use around the world. We see particular promise for the future of bioenergy use in India. And this is why we have established a dedicated webinar series of 3 webinars so far, but maybe we'll see more to follow, that is looking particularly on the opportunities and chances for using bioenergy in a sustainable way in India. In this webinar, we will look particularly on the role of biomass densification. As you are aware, agricultural biomass residues are very light material of low density, of varying humidity, and the precondition for every energy use of a specific material is to have it in a standardized form, in a form of high energy density, and then we can use it for a variety of purposes, of course. In India right now, a highlight is certainly the ambition to co-fire very large amounts of biomass in thermal power plants. But biomass could, of course, also be used in industrial use. It can be used by households if you have the right devices to do so. So there are a wealth of opportunities, but the precondition is always to convert it into a standardized, densified fuel. And that is what we're going to talk about today. And I'm very glad to welcome 3 distinguished speakers from very experienced companies that will talk about their experiences with densifying biomass, particularly with respect to India, the way forward they see, and also the advantages of the different technologies, because we have on the one side pelletization, on the other side briquettization. Both technologies have their specific advantages, and I would like to welcome our speakers now very warmly. We will start off with Pavan Pawar from Andritz, India, that has already established a number of pelleting plants in India. We will then pass on to Bo Andersen from CF Nielsen, a very experienced briquette machine manufacturer from Denmark. And we will end up with Christophe Garnier from Prodesa. Prodesa also a company that is producing pelletizing equipment and implementing it worldwide, I can say. So 3 distinguished speakers, and we will handle this in such a way that those of you that have questions, please share your questions in the chat. We will look at the chat and we will ask the questions that you put up in the chat after each presentation. Without further ado, now I pass on to Pawar. Please tell us about your company's activities in India.
Sure. Thank you. Good morning, good afternoon, and good evening, everyone. This is Pavan representing in Andritz. So I will be presenting about biomass in India. Before that, I would like to thank World Bioenergy Association for giving us this opportunity to be a part of this seminar. Before diving into the presentation, I would like to give a small introduction about myself. My name is Pavan. I represent Andritz Technologies. I'm working as a general manager sales for the South Asia. I'm managing capital sales and the plant solutions. With previous work with GIA Westphalia Separators, it's a German-based company. I was a country manager for India, Sri Lanka, and Nepal. I have a more than 10 plus 2 decades of experience. Of this presentation would be I will be covering about Andritz Group and its feed and biofuel and the biomass in India, the challenges what we face in India, the mandates and the policies and its contribution to biomass India. We do have and we would end up with a Q&A session. Andritz being the world market leader with
Pavan, we are having issues with the sound.
4 business.
I'm afraid you should turn off your camera. We cannot hear you properly. Pavan is frozen.
Now, am I audible now?
Yes, you're well audible now. Please go ahead.
Give me a moment, please. Yes, I hope I'm audible now.
Yes, you're audible now.
Okay, fine. I would start again. Andritz Group, Andritz being the world market leader with 4 business units. We are into pulp and paper. The market share in pulp and paper is 46%. We are into metals and the market share is around 21%. We are into hydropowers. The market share is at 18%. And then we are into environment and energy. So under the umbrella of environment, energy, feed and biofuel comes under this umbrella. And it's in numbers. We are around 30,000 employees worldwide, over 208 companies worldwide, and we are spread over at 40 countries. Earlier, I was talking about Andritz as a whole. Under Andritz, as I said, we have got different verticals. Now I'm talking about Andritz feed and biofuel. Andritz feed and biofuel, we have got different segments. We are into animal feed, aqua, pet food, biomass, and waste and recycling. Today, we will be talking about biomass. I will be focusing more on the biomass. If you see this globally, these are the footprints of Andritz. We are spread over all over the world. We have the service units. We have service and manufacturing. We do have earlier I spoke Andritz as a whole. Then I came as Andritz Feed and Biofuel as a entity, and now Andritz Feed and Biofuel in India. So we have a presence in India. We have a head office in Chennai, which is located in southeast of India. From India, we operate in India, Sri Lanka, and Nepal. We are around 84 employees. And if you see on the right-hand side, this is the number of plants we have sold in India, which is spread all over India, Sri Lanka, and Nepal. At the moment, we are altogether 136 feed lines that is in poultry, cattle, and aqua, which we are not talking today. We are talking only about biomass. So biomass, we have got 38 biomass pelleting lines. Okay, how biomass started in India? I just give a small background about stubble burning. What is stubble burning? It is actually a practice of intentional burning of straw post harvesting, and which is widely spread technique after harvesting of grain like rice and wheat. This is actually a very common practice in India, contributing to greenhouse gases. But what is the reason that people choose to go for stubble burning? Because it is a very cost effective. It is cheaper compared to an alternative removal methods. If you see the stubble burning, the effects and the solutions. What are the effects? Air pollution leading to poor air quality and health issues. Risk of fire, sometimes it can go out of control. Emission of greenhouse gases. And if you see the pictures on the right hand side, you can see these pictures are taken from the NASA satellite captured of image where the stubble burning happened in North India and how the smoke is spread all over North India. What is the alternate solution? The alternate solution is to reduce the pollution from the stubble burning, involve mitigation crop farming, adapt to diversification of agriculture, adopting the paddy straw farming technique and making biomass pellets and briquettes. Okay, this is biomass generation in India, small insight and key biomass categories. India being a diverse crop pattern yield which generates 730 million tons of biomass annually, out of which 500 million tons is being utilized for mulching, power generation, cattle feed, and steam production. Apart from that, another 230 million tons is a surplus biomass, which is just being burnt in fields. And the main biomass categories are like we have bagasse, which is of 90 million tons per year. We have mustard, we have cotton stalks, and last but not the least, the paddy, which is in ample in India. Where this biomass can be utilized. This is an integration part of in power generation. As you know, national NTPC, which is popularly known as National Thermal Corporation of India, which generates 25% of power in India. They have 27 power stations producing 52 gigawatt and 9 associate substation contribute to 7 gigawatt. If NTPC start co-firing of these biomass pellets, then they would be needing at least 30,000 tons of pellets per day. Beyond NTPC, India do have a lot of thermal power plants, which is of number 233 stations. Installed capacity is 330 gigawatt. Again, if these thermal power plants, again, they start co-fighting of 5% of agriculture biomass pellets, then they would be needing around 160,000 tons of pellets per day. And then we do have 200 coal-based power plants, which is a produce a capacity of 400 gigawatt. And as I mentioned again, if they go a minimum of 5% of biomass pellets, then they would be needing around 192,000 tons per day of pellets, which is quite huge. Okay, what drives this? I mean, if somebody wants to put a plant, what exactly drives them? It is something called like a biomass program. The Ministry of India, they have come up with a lot of schemes to support promotion of manufacturing of briquettes and pellets based on cogeneration in industry in India. And what is the objective of this? The objective of the biomass program is to support setting up of biomass briquettes and pellets manufacturing plants and to support biomass which are non-bagasse based on cogeneration projects in India, in industries in India. These are the periods which was done initially from 2021 to 2026, but in my coming slides, I would be saying that these are being revised for next 25 years. What are the selling features of this biomass program? The program offers central financing assistance to support project developers and service charges for implementing and inspecting agencies. How the funding is being done? Financial assistance available under this program is as follows: briquetting and pelleting. Anybody who wants to put a briquetting and pelleting plant, they get a minimum of 10 lakhs per metric ton manufacturing capacity and can go up to 50 lakhs per plant. Any plant which is going off non-pagas, the funding would be starts from 40 lakhs per megawatt and can avail up to 5 crores per million per project. So how do you avail this these benefits? I have given a link on this. If you can click on this link, and then you will this will directly take you to this the selling features, and you can avail the policy which was given earlier is being revised again. Earlier, it was not mandate that you need to co-fire with co-fire these biomass pellets with coal. Now, the Indian Ministry, the Power Ministry, have come up with a lot of mandates that 5% of co-fire should be done in thermal power plants from 2024 to 25. This is being come from the Union Ministry of Power and New and Renewable Energy. The Union Ministry of Power and New and Renewable Energy revealed that 47 thermal power plants have engaged in co-firing agro-residue based biomass pellets with coal already. The Ministry of Power made modifications on this date, revising again on 21. And as I said, the revised policy now it says from a minimum of 5% of biomass pellets has to co-fire with all the thermal power plants. The obligation is all set to increase to 7% from 5% from financial year of 25-26 according to the update policies. On the right hand side, if you see the update from the ministry, co-fired as of now, they have co-fired around 164,000 metric tons of agro-residue being co-fired in 47 thermal plants, but this is hardly I would say 1 or 2%, which now there is a huge delta gap in order to co-fire. The policy durations, co-firing policy is in force for the next 25 years, or the life or the thermal power plant usage life. Contract period, once a company get into a contract with NTPC, then this will go a minimum of 7 years. He can supply the pellets. Again, I have put down the policies numbers. Okay, now what is Andritz contribution? What has Andritz done in biomass in India? Andritz have sold 12 biomass pelleting plants, which is altogether, I would say, a 36 pelleting lines, producing of 550,000 metric tons of pellets per annum, and we do have a 40% market share in India. We have got a lot of projects, and at the moment we have got ongoing projects. We are building a biomass pelleting plant on bamboo. The raw material is bamboo, where we giving a capacity of 325,000 metric ton per annum. This is one plant, and another plant which is on a mustard husk. I would say that is a 200 tons per day, which is nothing but 63,000 metric tons of pellets it gives annually. This plant is coming in Haryana, which is very close to Delhi NCR. And then we are also working with a company called Jindal Power, where we have got backed an order for a biomass pelleting plant on rice straw. The capacity is 48,000 metric tons per annum. So this is the global endeavors collaboration on world's largest. Apart from this, and it is working with a company in India where they wanted to go for a world's largest biomass pelleting plant, which is of 1.2 million metric ton per annum. The beauty of all this project is, and it does all turnkey projects. Like we give a turnkey projects from dumping till packing. So the customer has not to worry anything about any kind of multiple vendors working at site, but they have to just approach Andritz, and Andritz can give a complete turnkey project apart from civil. Apart from all these projects, Andritz is also involved in world's largest ethanol plant. This is based on bamboo. The typical flow diagram of biomass pelleting plant. As I said, we start from dumping of raw material. We go for grinding, we go for drying, and then we go for pelleting, cooling, sieving, and packing. So it is the complete is shown in one picture where we use all this machine which is shown on the bottom. The references. Uh, as you know, Reliance Industries is one of the largest company in the world. They have two world's largest refinery, which is located in Jamnagar. India will fully move from fossil fuel to renewable energy in next few decades. These are the words from the chairman of Reliance, Mr. Mukesh Ambani. Reliance, who operates two giant refineries with a combined capacity of 1.4 million barrel per day in Western India, which is in Jamnagar, aims to become net zero carbon by 2035. To start with, and they have given an order to Andritz, and this plant been installed in 2023 and is being running successfully from past 2 years. They have gone with a lot of raw materials. Reliance is the only company who gets ample of raw material and different kind of raw materials. Our plants are running on these various raw materials. We have Juliflora, we have cotton stalks, rice straw, wheat straw, rice husk, sugarcane thrash, bagasse, and a little bit of sawdust. These pellets are being co-fired with their refineries. As I said, they have got two world's largest two refineries, and then they co-fire with the coal. Apart from Reliance, Andritz have got back the largest plant in India. This plant is of 1,000 tons per day, and this is the raw material would be on bamboo. The company name is Rashmi Metallics, which is in West Bengal. Then we have recently commissioned this plant. This plant is of 200 tons per day. This with on a biomass pelleting plant, the raw material is cotton stalks and rice straw, which is running successfully. This is the only plant in India, I would proudly say that is the only plant in India which is running properly on rice straw, and is supplied by Andritz. It's a complete turnkey project. This project, as I was talking about the ethanol plant, this is the world's largest ethanol plant where the raw material is bamboo, and a part of the complete plant is given by Andritz. Like we have given the intake section where the bamboo is being come to the plant. We clean this bamboo, we chip the bamboo, we store it, and then we again sieve it, and then we send it to the next process. So this complete plant is given by Andritz. Okay, what are the key takeaways of my presentations? Like Andritz has been playing a pivotal role in driving biomass development in India, contributing significantly to a sustainable future through 12 biomass pelleting lines, producing 550,000 metric tons per annum. Currently, as I've mentioned, we are working with 200 and 160 tons biomass pelleting line, which is under commissioning. At Andritz, we prioritize a comprehensive approach, executing all projects as a turnkey projects. As I said, I can vouch for it. Andritz is the only company in India who gives a turnkey projects. Our success lies in combining Andritz technologies with a global team of experts and excellent post-service support. As I said, we have a team of 84 people. We have got engineering team, procurement team, commissioning team, after sales. We do have spare parts. As I said, again, I can say that Andritz is the only company who keeps a spare parts of 1 million euro in India, where we put down in our contract says that we can give a service within 24 hours. Yes, that's all from my side. If any questions, please let me know.
Wonderful. Thank you very much. So can you please unshare your screen, and then we can talk about the questions that came up in the chat. So, first question to you, Pavan, can you elaborate a little bit about um, what is relevant in terms of types of biomass? Because there was one question, can you use any type of biomass for pelletization, or is that kind of limited to certain plants? What about the humidity? Can you tell a little bit about the experiences that Andritz has with respect to
Yes.
I mean, there are so many different types of biomass.
Yes, as I said, India is a vast country with a lot of biomass available across the country, and we are very confident that any biomass which is available in India, we can pelletize in India, because our Reliance is one of the best examples. Reliance has got almost 8 to 10 different kind of biomass, which we have taken trials, and uh, the capacity what we have promised, it is a 80 tons per day plant, where Reliance is producing 95 tons per day. So definitely we are very confident that any biomass available in India can be pelletized in Andritz machine for sure.
But I mean, more advantageous is to have dry biomass, correct?
More, sorry, come again?
I mean, the humidity plays an important role in terms of also the costs, in terms of investment, in terms of operating costs, because drying the material takes a lot of energy. So can you elaborate a little bit on the role of humidity and how you deal with that? Do you typically have a drying installed when you do processing plants? Few words on that subject.
Yeah. See, as I said, that like India has got different kind of biomass, and mostly is what available is the straw. But straw doesn't have moisture. The straw has got a moisture of say less than 17%. So we don't need any kind of dryers. But when you go for bagasse or mustard, definitely on a season basis, definitely these comes with a moisture of 40 to 45%, where we have to have a dryer. So and it's supply a dryer as well in their solution.
Right. There was a question that I think I can answer. The question was, what is the difference between pellets and briquettes? And fundamentally, it is that pellets are small pieces, like 2 or 3 centimeters, with a diameter of 6 or 8 or 10 millimeters, whereas
Yeah.
briquettes are big pieces. They are like with 5 to 10 centimeters of diameter and 20 or 30 centimeters of length. So it's mainly the size. But
Yeah.
apart from that, it's dried, densified biomass. So there are different ways, different forms, and different advantages, and we'll hear more about that as soon as Bo Andersen is speaking to us. Maybe just one last question to you, and that is, you have been referring several times to turnkey projects. I know many project operators that want to cherry pick, so they want to have a low-cost supplier of hammer mills, and then they want to have a low-cost supplier of pelletizing equipment, and then they have a different supplier of the conveyors. Obviously, turnkey projects are more expensive than that. Why would you still suggest customers to do turnkey rather than to, cherry pick and put together your own plant?
This basically depends on the customer, because if a customer and its price fit customers pocket, then definitely they would go for Andritz. But when any customer sees Andritz plant, even if he's thought of buying a hammer machine or pellet machine, but after seeing the complete plant, he would rather go for a complete plant, because he's damn sure that he gets pellet out of it. But if he tries to make a pellet machine from Andritz and try to take things from the local, then at the end of the day, he has got multiple vendors, where sometimes it becomes a blame game that this is not working fine, that is not working fine. So more, and as you know, biomass is a very bad source. I mean, a very bad raw material, which is not easy to pelletize, or is not easy to run a plant for 20 hours. But and its plants are running for 24 hours a day without any hassles.
So the advantage of a turnkey plant is really that you don't have these breaking of responsibilities between the different suppliers. Because if
Exactly.
the conveyor does not fit the hammer mill, then you have an issue, and the hammer mill manufacturer will say the conveyor is wrong. The conveyor will say the hammer mill is constructed in a wrong way, and you will end up with all kinds of disputes. And I think that's one of the
And
issues.
I would not say Andritz is expensive. I would say Andritz has got a premium price. So if you need something good, you have to pay a premium price for sure.
Thank you very much. So
Thank you so much.
thank you very much. So now we switch from pellet manufacturing to briquette manufacturing, and I would like to give the floor to Bo Andersen from CF Nielsen. Bo, please give us your views. Tell us a little bit about the experiences of CF Nielsen in producing briquetting machines.
Yes, thank you very much. And you can hear me, right? Hello? Okay, I cannot hear myself, so it gets a little bit weird here.
We can hear you very well. We can hear you
okay, that's good. Anyway, I will do my presentation here and explain a little bit about how CF Nielsen is and how we have developed over time and the things that we can provide within the briquetting field. I think we'll leave the questions until later because we for sure have some answers to that about the differences between pelleting and briquetting as well. Okay. CF Nielsen is a very old company which was founded in 1889, so more than 130 years ago. It was started up, and if we take it here, it was founded by Carl Friedrich Nielsen, whereof the name comes. He did shorten it up a little bit to make it a little bit easier for everyone to say, I guess. But it was not until in the 40s, during lack of fuel in the world and this, that the first briquetting press was designed in the company. This has, of course, then developed over the time to be what it is today, which we will get more into later on. The company owned the family owned the company for around 100 years, whereafter it was sold out of the company to and a separate entity was founded, but keeping same name. 2016. CF Nielsen established what we call CFN Engineering, which we will also get into a little bit later, what that includes. Also in 2016, we made what is today the world largest or the highest capacity briquetting press in the world. 2017, we acquired an extruder press, which was developed in Japan many years ago as well, which is the reason why it's called Shimada. In 2018, the German company Ruf, which is the leading manufacturer as well in briquetting technology, acquires CF Nielsen. The differences between our assortment we will also get into. As Pavan also mentioning before, it is possible to, you can say, briquette basically any agricultural raw material. The issue is that we as well require a dry or relatively dry raw material. We need the particle sizes to be relatively small. To compare a little bit with the pelleting plants, normally you see that a briquetting plant is a little bit more simple, meaning that it is also able to handle bigger particles and as well is able to run smoothly with a bigger variety of moisture content. So that's one of the main differences that are between the two. Then we, of course, are able to produce briquettes from wood of basically any kind, which was where it all started. It, of course, has developed over the last maybe 10, 15 years, things like torrefied wood and other kinds of torrefaction technologies that needs densification as well. Here we have it again. You can say our requirements. We need a homogeneous raw material. If in case that companies have a lot of different raw materials, they basically have two options. Either they set up the machine for one raw material and runs it for a period of time, whereafter they change over with new die sets and stuff and parameters in the machines and run the other one. Otherwise, it's of course also possible to mix the raw materials, but it is important that the mix is well done and preferably, you can say, controlled in our system so that we are able to say we potentially run 50 or 30% of one and 70% of another. And it goes through a mixer before it goes into the machine. In that way, we will basically create a new homogeneous raw material. Moisture content between 6 and 16% is what would normally work. And that means I would say 95% of the raw materials will work within this range. Some will even work a little bit higher, but it's again an individual examination, you can say, whether it will work or not, and tests would definitely have to be done when we get outside of these ranges. Particle size, we would normally say you need a particle which is 20 by 3 by 2 millimeter or smaller. And that is partly to, of course, to be able to feed it in well and get enough capacity into the machine. Then another issue, which definitely is something to take into consideration when we're talking agricultural raw material, is like how clean the raw material is. Ash content is important, and especially the silica content in the ash is important. We, of course, prefer to have it as clean as possible, but below 0.5% is definitely only clean wood that will be able to get to that point. Straws and other agricultural raw materials that surely have higher ash contents like this than this, and also it can be difficult, you can say, to clean it before it actually goes into our equipment. This would then influence, you can say, the costs or the wear for the parts which are in contact with the raw material. Here's like a sample picture of a lot of different raw materials that can be briquetted, different forms as well. You see most of these are made on what we call mechanical briquetting machines coming from CF Nielsen, where you have
Oh, we cannot hear you right now. Something is wrong.
Yeah, he left the session.
Okay, Bo fell out of the session. That's too bad. Okie doke. So what are we going to do now? Let's wait to see for a moment if Bo can reconnect. Does not seem to reconnect at the moment. Sorry about this technical glitch, ladies and gentlemen. Our speaker has fell off the cliff of connection. So I think here he's back. He's back. Okay, Bo, you're back. You fell out of connection. You still need to connect to the audio signal. We cannot hear you yet. Unmute your microphone.
Can you hear me now?
Yes, now you're back.
Sorry about this. Okay.
There's always a risk with the webinar. Bo, you're now fine. Just
okay.
Return to full screen mode, please.
Yes.
And you can take it from there.
Okay, great. I hope this was where we were. All right. The capacities from 250 to 3.5 ton are also related to what you can see below, which is the size of the briquette, which was one of the points from before. You can say a smaller capacity machine will also make a smaller diameter. So going upwards from 50, 60, 75, 100, 90, blah, 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 up to 120 millimeter. And with a 120 millimeter machine, you will be able to produce 3 to 3.5 ton per hour. So this relation you would always have. A thing which was talked about before regarding the size is that the diameter is like given and related to the capacity requirement, but the length of the briquette is something that we can control. We have different devices so that we are able to cut or break off the briquettes in a given length, down to about 10, 15 millimeter as the smallest one. We would call that POX, and which could be very suitable for automatic infeed system in industrial boilers or similar. Okay. Densities that are obtainable, 0.9 to up to 1.2 in the actual density of the briquette. This is again something where you would look into what would the requirement be. For an industrial boiler, often the requirement for density is basically that you would like it to be solid enough so that it doesn't break up during handling or transport, but you don't need to make like a solid rock, because this influence on your capacity of the machine. And potentially also when you have infeed, it might be an advantage that it actually breaks up a little bit easier. So that is something we can control for sure. Production cost, yes, relatively low, but we get back to that a little bit later also. Short here, just about the extruder press. These are made for when you have very high density requirements, like up to 1.4, it generates a very nice consumer briquette, which is also sometimes known as Pinnacle briquettes. Also, in case a customer wants to carbonize and use them for barbecue afterwards, this is the machine to use. Short again about the hydraulic lines from our mother company. Mainly rectangular briquettes can be used for, of course, for wood or biomass as well. Similar requirements for the raw material, but typically you can say the market for this kind of briquettes is the private consumer market, more than for the industrial market, which is more typical in India. Here you can say we say that briquettes are a strong alternative to pellets, but in any case, this depends on what market, what is the purpose of the fuel. How are the in-feed systems? All these things need to be taken into consideration. Our strong points is that it is generally a lower investment, especially for lower capacities. We have significantly lower operational costs. It is typically easier for customers, especially if they have variations in their raw material, to get a briquetting line to work. Anyway, you can say here we are showing industrial solutions, agricultural solutions. It's based on the same briquetting presses, the same briquetting press lines. So it is more like how are the preparation line, what is the preparation requirement before the briquetting, and how are the accessories, you can say, which are supplied with the machines. This as well shown as just for the consumer solution, which is when you have briquettes sold for the private consumer, probably not very relevant in the Indian market, unless there could be an export opportunity. But in this case, we are still based on the same machine, but there will be a cutting saw as well as automatic packaging at the end. One solution that could be interesting and which we have talked with several Indian customers about is the mobile solution, where the briquetting press is integrated into a 20-foot container. This you can set up, you can say, or move to another place within one day. This is, of course, an advantage in case you have different kind of crops where you need to move the briquetting press, or you have different areas where you harvest from, where it would make sense to get it closer to the raw material. It is, though, something again to take into consideration, because in case drying, downsizing, etc., is required before the briquetting, it might not make sense to make a mobile briquetting solution if you still have a stationary dryer. So again here, something that needs to be looked into for any individual project. Here you have the range again for the machines, as well as the briquette sizes that comes out of it. as the presentations here are going to be shared afterwards, I'll not go into the individual machines here. Here you can see just the basic principle: material flow coming in at the top, distributed into two different chambers. You have a pre-compression via some pre-compression screws on the sides. So you're feeding in from both sides, which is a great advantage for low weight or bulky raw material, which agricultural waste often is. Then you have the compression chamber, where the raw material is put in front of the piston, and it goes through the conical die system. Control systems, we will pass that fast as well, but everything is controlled via our touch panel and PNC control, and you are able to monitor and even control from remote. This is also a great advantage on that we will be able to access our PLC from anywhere around the world, basically, and from the factory in case of servicing. Engineering that we mentioned before is that we, if the customer requires it, can go into the discussion and help with regards to often like drying systems, like downsizing equipment, to be able to provide a raw material that would work in our machines. We do not manufacture these things, but we have found that it is often necessary and a good idea if we get involved in this and discuss it. And then we can help our customer choose right, whatever they want to do. This could be an example of a wood-based setup, where you would have chipping, you would have drying, you would have hammer milling with intermediate storage on before it actually enters the briquetting lines. Similar setup here, but for a straw setup. But again, here with downsizing, with drying. Then I just will mention some of these features that are included in our machines, which is, I think, relevant in relation to India, where there is quite a few companies supplying briquetting equipment as well. The dosing screws making the feed in, the infeed of the material is controlled by our control panel. And for example, when you want to mix raw materials, you'll be able to control it very precisely. We have a possibility of adding different kind of binders or additives into the briquette in case that would be necessary. I would say 85%, 90% of the time it's not necessary, but it could be for some very difficult raw materials where it's possible. We have automatic preheating of main and extension die, meaning that when the machine needs to start up, it will heat up the dies, which again makes it much easier to push out the briquette, which has been very hard inside the die from the day before. I'm sure that is something which has been seen as a problem in India before. So by doing this, it is eliminated, this problem, and you can have an easy start. A second thing or positive thing about this is that you already have the right die temperatures before you actually start producing. So that means that often you would see, if you're not using systems like this, you would see that you can have bad briquettes from the beginning until this temperature is reached. When we reach the temperature we want, we switch on water cooling, which means that we keep the temperature that we have set on the control panel. So we keep a constant temperature there, which is of course also helps for lifetime on the dies, but also keeps a constant environment for the production. Yeah, as I mentioned before, we need, when you change raw material, you probably need to change the dies, which means that you have like a conical die, which is fit to the specific raw material. When you add another one, you maybe need to make it more wide or more close to make it work in the optimal way. Further on, we make it with different materials, the die sets, with regards to abrasive raw materials. Special wear parts with interchangeable parts has been made for abrasive raw materials like straw. Change of a die system can be done with standard setup in around 1 hour, and with some special options included, we will be able to do it in down to 20 minutes, which is also a big advantage when you have the raw materials which are abrasive. For sure, manufactured for 24-hour operation. And if you're having a full line with drying and downsizing and everything, we are typically able to run 85 to 90% of a 24-hour day. It can basically run unmanned, and we have fully automatic start and stop based on the levels of raw material in our buffer silo. So in principle, there would be no requirement for people around. We would normally calculate with having one man 1 hour per day to do a little bit of cleaning and greasing and whatever. But that is very, very limited. Yeah, of course, we can produce basically because of the controls and all this and the die setup. We can produce uniform briquette quality and quantities. Power consumptions, 35 to 40 kilowatt per produced ton, which is also a difference to a pelleting plant for sure. Lifetime of the presses, very long, I would say. We have very old machines still running, 30, 40 years old, but typically 10 or 20 years is a typical setup. Last thing here, we normally assign a project manager to every individual project, big or small, to ensure that the customer get what they want and what they require. Finally here, you can say brief overall requirements to reach that goal that we would like to have. And that is the raw material as one. It needs to be available in a reasonable way. It needs to be uniform. And of course, it adapted to the individual project, the people involved, management, as well as the operator must have, you can say, a mindset for this. There would definitely be education in operating the machines, but it is surely important that that the mindsets are right to get a positive outcome of a line, and that is independent on whether it's a pelleting or briquetting line. Equipment, yes, that's the last of the three. Where I say you need to have, of course, quality equipment, which are specified and set up for the specific project, and yeah, to get optimized visibility over the long run. High investment, but it will come back, I'm sure.
Thank you so much, Paul.
Thank you very much. Here's some contact details, and that will be on the presentation as well.
Thank you very much, Paul. There was
Okay.
one short question for you that I will ask you, and that is, do you have a presence in India?
Do I have a what? Sorry?
Presence in India. Do you have an office in India?
We don't have an office in India. I handle the Indian market from Vietnam,
Okay.
where I'm based. So this would be on an individual basis, and we of course come there, but we don't have a setup in Vietnam.
Okay.
No, in India. Sorry. Yeah.
Thank you very much, Bo. And with that, we will, and thanks a lot also for giving these detailed explanations of the differences between briquetting and pelleting. I think that was very, very helpful. With that, we come back to pelleting. And I would like to introduce our last speaker to you, Christophe Garnier from Prodesa, which is a very, very experienced also pellet plant manufacturer. The floor is yours, Christophe.
Thank you very much, Christian. Thank you. So I'm going to share my screen. Okay. Can you see my screen now?
Yes, just
Good.
go to the full screen mode, please.
Okay, yeah, absolutely, you're right. Okay, I don't know that. Okay.
Yes. Excellent.
Thank you. So let me present first a bit the company, and after that I will go in detail regarding the agro material and agro pellet. So, okay, So Prodesa is a worldwide company. We have different branches in North America, France, Asia. We have opened recently a branch office in India, and we are also present in Baltic states. And our main office is in Spain. So the activity of the group, Prodesa, is a turnkey supplier. So we are designing, manufacturing, and supply complete plant for wood and for different biomass, including pre-treatment, including biomass dryers and pellet mills. We are also manufacturer, so we are manufacturing capital equipment like hammer mills, pellet mills, dryers, and many other components like conveyors. Also, we are providing a after-sale service in the different country we are acting. So we have a team dedicated for after sales in many countries. So as I was mentioning, our headquarters is in Spain. We are branch in worldwide. This is some picture of our different facilities. So we are a major player in this biomass sector since almost 20 years, 25 years, acting in Europe, in Russia, America, and Asia. In those pictures, you can see different units that we have built. Some of them are quite large in size, and others are smaller. If we go to details regarding agro pellets, so the one very something important to say regarding the agro material comparing to wood, that usually they are not stable in moisture. So they can have a high or variation of moisture content. Also, the quantity of sodium, potassium, chlorine is higher than what you can get in wood. There is, for the majority of agro materials, there is high quantity of ash, and also that those quantity of different minerals are creating low ash fusion temperature. So that's a major difference with wood. And to produce pellet or briquettes, will make the transport and the handling of those agro materials more efficient and less expensive. And also, it will allow to put some additive to neutralize the effect of the chlorine and the alkalines. So that's a very important, it's the pellet himself is not helping regarding combustion, but the addition of some additives can help for the final combustion. In this picture, you can see different package, different lines to get the pellets. So regarding the first step, when you are using bales in a process, is the bales filling system, and all the question you have to consider is which size of bales you are going to use. Are they going to be round or square? What will be the density of the bale? The strings material is also important, and do you have different raw material? And as well, to define properly this line, you have to take in consideration the seasonality of the supply of each raw material. And in Prodesa, we strongly suggest to have this to have some buffer of storage of bed under roof, so in a hangar or in a building, and also to put all the line, the preparation line, inside roof, and to control the raw material moisture content of the bale. If you have a bulk material like for example husk from different seeds like rice or wheat, etc., you can use a feeding system for bulk material, and you have to also understand which would be the number of raw material you want to fill together, if you want to mix the product or if you have seasonality of each material as well. And you have to be careful with the self-combustion or the explosiveness of the bulk material. There is some material when they are dry that they are very stable in terms of risk of explosiveness, but you can have self-combustion as well. So you have to be careful about that. The size of the particles, the density, the moisture of each bulk material are very important for us for the design of the line. So we have, as mentioned by Christian a bit before, the density of dry material is very light. So we have to design the conveyors and all the equipment, taking that in consideration. Our suggestion for that part is also to have a roof to protect dry material. And for wet material, you can put that outdoor, okay? For these materials, dust section and filtration are mandatory. Spark and temperature detection are also very important because you are going to produce a fuel. So that's logic that you to take care about spark and fire detection inside the process. And also we strongly recommend to have internal control for physical and chemical parameters. When you are going to use bale, one of the first step will be to have a bale breaker to destroy the bale, to mill, in fact, the bale. So again, the question of the size and if it is round or square, and the different material you would get is very important. And we also suggest to have this line indoor with dust aspiration and spark detection on this bale breaking system. If you have raw material wet, or when I'm saying wet, higher than 15% moisture content, and with big particles, we recommend to go to a pre-milling machine. So to go with a pre-hammer mill to pre-mill the material to get it small enough for the downstream process would be the dryer. You can dry some big particles in size, but what is very important is to have a thin particles. To have, in fact, what we need to do is to have a particle very small in thickness to get an efficient drying. Okay, you can see in the picture the kind of material we need to get to go to the dryer. Then here you have some picture of the milling line. pre-milling line before drying. And again, always the same questions regarding the material. What is the size of the material, the different material you want to mill, and the moisture content. And this line have to be inside the building. And because you will get most probably quite dry material, even if they are not dry enough for the pelleting process, you have to take care about dust aspiration, filtration, and also spark detection and firefighting system in this line. Regarding dryer, so we were talking about that a bit previously as well, that you have to dry the material if they are higher than 10–15% moisture. It depends, of course, about the kind of material you can get. There is not the same moisture tolerance for depending of the material you will want to pelletize. And regarding dryers, we can supply you, we can deliver you two technology. So drum dryers with high temperature and belt dryers with low temperature. There is a mistake in the presentation. Sorry for that. So the low temperature belt dryer is working with usually with waste energy or with coming from cogeneration or biomass boilers, and is providing you very high pellet quality and minimal fire risk, because we are working with low temperature. And also you can grow, you can extend your dryer because they are modular in terms of design. The drum dryer is working with a high temperature, so it's a high efficient technology, low power consumption, and automatically operated and controlled. Here you have a presentation of our low temperature belt dryer. That's an example for sugarcane bagasse. So you have a feeding system with twin screw to make the layer of the product inside the belt, and you have the exchangers who are on the top of the dryer. We are supplying hot water in those exchangers, and then the air is crossing the exchanger, and then is crossing the product and the belt, and there is fans who are sucking the air with the steam, with the water extract from the material. At the end of the belt, you have a dry product that you can go to the next steps, will be the milling and pelletizing. In our belt dryer, we can work with hot water. We can work also with low temperature steam, with hot air, and with a combine of different things like exhaust gas and hot water, for example. So we can. Let me go to the next one. So here you can see the efficiency of the dryer for sugarcane bagasse, for example. So in one side you have the temperature of the hot air and coming from the hot water, and in the other side you have the drying surface. So if you have very high quantity of a very high temperature of air, you will have a small dryer in surface. And if we are considering to work with recirculation system of the material, we can also decrease the size of the dryer. The next step after the dryer will be to mill the material. So we need another step of milling to create a powder after the drying line. So we are feeding this dry material inside a dry hammer mill with it's an equipment working with hammers and screen, high-speed hammers. And we can produce a very small product, around 3–4 millimeters size. And then this material we can use it inside the pellet mill. Here you have some photos of the dry hammer mill. So same question to ask when we are designing hammer mill, what will be the size of the material if we are going to get different raw material and the moisture content we will get. Okay, we can avoid to have the to have the wet milling line and to have the dryer if the product is thin enough and dry enough. Before to go to the pelleting line, we are going to mix the different material, and that's an important operation, especially when we have different raw material. If you want to make a pellet, a compound with different raw material, you have to mix them previously to the pelleting line. That can be a batch operation or can be continuous operation. And also in this mixing, it's the place where we will be capable to dosify and to add additive to neutralize the effect of the chlorine and the alkaline. And that's those additives will depend, the quantity and the kind of additive will depend of the material you will pelletize. The last steps in the process will be the pelletizing. So we are supplying pellet mills with ring dies, with a very low wear cost of spare parts, very simple equipment to maintain, and very we can work with very big wide of range of application. We are capable to work with many kind of agro product or wood. You can see here some pictures of different factories working in wood and agro. So here is a line of 15 pellet mills of 5 tons per hour. That's one single machine of 5 to 7 tons per hour, depending on the raw material you will pelletize, and some other lines. After the pelleting line, you have the cooler. So the cooler is a counterflow system. The pellets who are going out from the pellet mills are around 100 degrees, a bit less, 90, 100 degrees. And we are cooling with the air, with the ambient air, to a temperature close to the ambient air plus 7-10 degrees. And after the operation of cooling, we are screening the pellets to take out the fines and the broken pellets that we can generate with the handling between the pelletizing and the cooling. Very important thing in the pelleting plant is the control and the programming of the equipment. We have many machines working all together, and the SCADA, it's a very important thing to control automatically without many people involved, the complete operation of the plant. So Prodesa is developing all the SCADA for the full line of the pelleting process. So integrating the dryer, integrating the preparation, the dry milling, wet milling, pelletizing, etc. I'm going to show you also some example of plants we have done recently working in agro. So that's our last reference for agro project. We have done pelleting and drying plant in different countries for bagasse, for peanuts hulls, for straw, and for fruit pulp, etc. So that's one big line we have done in Mexico. We are doing right now in Mexico for 8.5 tons per hour of sugarcane. That's plant developed in Serbia for alfalfa and straw pellets. This is one plant also done in Spain for straw and alfalfa. Okay, that's another plant in alfalfa. That's a factory. We have installed pellet mill in Brazil for sugarcane. etc. So I'm going to show you also some drying line we have recently developed thanks to together with our partner Swisscombi for bagasse in Thailand. So different plants we have developed in Thailand for to dry bagasse, and also one unit in China. Okay, I'm done. Thank you.
Many thanks. That was very, very comprehensive and interesting. Thank you, Christophe. And I would like to thank you particularly for also mentioning the safety aspects, because the safety aspects are very often underestimated or not taken in account for. I mean, obviously, all project developers want to save money. So very often, spark detection, we don't need that. We don't have sparks. And safety is really an absolutely critical element of a pellet plant. And that also applies to the topic of dust suction. Elsewise, you have very heavy load of dust in the factory and you have health issues with your employers. You mentioned self-combustion. It's also depends, of course, of the raw material, but we have had lots of fires. I should let you know that in Canada, at a point in time, it was not possible to insure a pellet plant because so many pellet plants were affected by fires or dust explosions. So the insurance company said, no insurance for that type of company. Now they have implemented very stringent health and safety procedures, and now it is possible again to get an insurance. But this is a topic you should definitely not underestimate. I'm very grateful that you mentioned that several times, how important health and safety is in terms of really having a sustainable project. Because putting up a pellet plant is fine, but if it burns down after 3 years, everything is lost. So it's really important also in countries that may have a specific attention to low investment cost to pay attention to this subject, because of course you can reduce your investment costs if you save on safety, but you can pay a very high price for doing so. And you probably don't want to do that, in retrospect at least. You have mentioned the control of the whole plant from one control panel, Christophe. And I mean, I had many conversations with African pellet mill developers, and they all said, no controls, just on-off buttons. What would you explain to these persons? Why do you believe, or why are you recommending for an Indian audience to not have just on-off buttons on every single conveyor, because that's more easy to operate for the operators? What's your answer to that?
Yeah, first of all, if you want to build a factory with a high capacity, when I'm talking about high capacity, 30, 60, 90 or more thousand tons a year, you are going to pay a lot of attention on the availability and the efficiency of your factory. And if you do something very manual, like you were mentioning, you can lose 20-30% of efficiency very easily, because you are going to put the control in your people. And that's what we have done a long time ago, and we know that it's totally inefficient. So if you want to have something efficient available, you have to have a SCADA, you have to have a remote control system to operate the plant very, very automatic. because if you give the right to people to turn the button, to turn everything, they are going to work at low capacity. They are not going to put the maximum of each equipment. Pellet mill have to work 95 of their load. Same thing for hammer mill, same thing for everybody, for every machine. So to get an efficient plant, high capacity factory, you have to get something fully automatic.
Thank you.
And also if you have different suppliers, if you go, like you were saying before to my colleague, if you go to different suppliers, you cannot have this complete fully automatic line. You can have different setup, different HMI on each machine, but you cannot have a complete efficient factory. So that's also, you can get something cheaper as you to buy each single equipment, but you will never get a high level of efficiency and a high level of availability of your factory.
So that's really a main argument for buying a complete plant rather than buying individual machines.
Yeah, and the ramp up as well, Christian. The ramp up, the time to get the good performance. I am in this field since 28 years already, and when we did the first factory in France and in Austria many years ago, everybody was doing by equipment, and it was taking 2 years to reach the nominal capacity. When you go to a turnkey, you can get it in 3-6 months, depending of the skill of your people. But if you do that by yourself, you will need years to get the high level of performance.
Thank you. Now, let me ask Bo and Pavan to also join for a kind of final round of discussion. If the three of you are looking at the market in India, what is it that you find particularly encouraging, and what are the concerns that you have if you think about the market for densified biomass in India? What are the worries if you look at this market? What are the promises? Pavan, let me ask you to start because you were the first speaker.
Yeah, hi. If you see the India market at the moment, recently we had the elections, and our Prime Minister, he won for the 3rd time, and this government is promoting biomass like anything. They are looking India at a different level in renewable energy. So definitely there is a big boom in biomass for the next 5 years. The only challenge is like how the customer gets a raw material and how we get converted to pellets and where he sells. So he has to concentrate basically on the raw material where he's located within a radius of 100 kilometers and can sell the pellets with a radius of 100 to 200 kilometers. So that will be the main. I would like to tell all the people in this forum that try to concentrate on the raw material which is available within their area, and try to find out which are the customers nearby, a thermal power plant or a company who's require steam boiler, who's got a steam boilers and all, who wanted to generate steam, so they can venture them. But definitely the market is really good in India at the moment.
Thank you, Pavan. Bo, what's your view?
Yeah, I basically agree with that. The raw material availability is of major importance, and of course you need some offtake. The closer the better. But as it is densified material which is dry already, it could be transported. But the logistic part in all this, whether it's pellets or briquettes, is very important.
Absolutely.
And you can say the safety of the deliveries of raw material and availability for sure.
Yes, yes. Thank you.
Yeah.
Christophe, your considerations regarding the Indian market. Why did you open a subsidiary in India?
Because of this amazing potential, and we, as mentioned by Pavan, because of the rules that the government is supporting is really high. And from my experience, what I can say is not to try to reinvent the wheel. Just be conscious that we have done in the world many improvements regarding the normatives, regarding the ISO for the pellets, to try to follow, to understand why what we have already done, because you can have if you are not doing the right pellets, you can have many problems with the combustion. So to be very careful on that, and to control well the chemical criteria, because to make pellets, it's not complicated if you have the good technology, but to be very careful about the raw material, and not only in terms of offtake, but that's most important, but in terms of chemical criteria, because agro material is not wood.
Thank you. You raise a really important issue, and that's also why we, as the World Bioenergy Association, have set up this series of webinars. Reinventing the wheel is very expensive. It seems cheap. Producing densified biomass seems simple and straightforward, and it isn't. And in other parts of the world, in Europe, in North America, in Vietnam, in China, very large amounts of pellets are already being produced, and a lot of experiences have already been made. So we really, as an organization, want to make these experiences available to prevent mistakes right from the beginning, because we know from other countries mistakes are inevitable. They will take place, and the more you take advantage from the learning that has been taking place in other countries, the more successful you will be. So that is our mission. And one last point that was mentioned by a participant, we should also address market issues, not just technical issues. I think that's a very valuable point, and we will do that in the near future. So we will also look at what is the market for densified biomass globally like, what is the market in India like, and what does that mean for local producers in terms of producing for local markets or producing for global markets. So thank you all, ladies and gentlemen, for joining this webinar. I wish you a good rest of the day, and I hope to see you again in one of our future webinars. Goodbye, everybody.
Bye-bye.
Thank you very much. Goodbye.